All right, so what we'll do today is just finish section 10.4. And already we talked about, I know we talked about measures of central tendency, talked about how to find the mean, the median, and the mode. The mean, of course, you have to take the average of your numbers that are given, and then the mode is the most frequent number in that data set. Sometimes there may be more than one mode or no mode. The median, of course, would be the middle number when your data set is placed in numerical order from least to greatest, preferably. And of course, if you have an odd number of data values, that means the middle number will be your mode. An even number of data values, you have to take the average of the two middle numbers. And we did a few examples of those, and then we talked about how to choose the most appropriate measures of central tendency. Pretty much, it also depends upon the data value, the data set that's given to you, okay, to determine which one you have to use, either the mean, the median, or the mode. All right, let's look at measures of spread. Now, to tell how much data is scattered, we develop measures of spread or dispersion. And the simplest measure of spread would be the range, okay? And that is the difference between the greatest and the least values in the data set. So if we want to consider this data set that we have here, like 20, 22, 22, 25, 26, 27, 27, 28, 30, and 35, to find the range, is the upper extreme, which is 35, minus the lower extreme, which is 20. That's the greatest minus the least. So if we subtract 20 from 35, you'll get 15. So the range of that data set that's provided here would be 15. All right, now, there is another measure of spread. We call that the interquartile range, or in short, IQR. And of course, the interquartile range is nothing more than the difference between the upper quartile and the lower quartile. And in this case here, the lower quartile, which is considered to be the first quartile, or Q1, that's the median of the lower half of the scores. So like in this data set here, the same data set that we looked at from the beginning. Here we have 10 data values. So we have to look at the bottom 5. We split the data set in half. We have the bottom 5 here, and then the top 5 right here. So for the bottom 5 data values, you can see here the median is that middle number. That's going to be 22. So the median is 22, or the first quartile. That represents the median of the lower half of those scores. And then for the upper half, which is these numbers here from 27 to 35, the middle number here is going to be 28. And that represents Q3, which we call the upper quartile or the third quartile. That's, of course, the median of the upper halves of all scores. Now, I need to mention some things about Q1 and Q3. For Q1, which is the first quartile, approximately 25% of the scores lie at or below the first quartile, which is Q1. Whereas with Q3, which is the upper quartile or the third quartile, about 75% of the scores lie at or below Q3. And of course, the median is the second quartile, which is Q2. So in this case here, we already found out what the median was here. You just take the average of the two middle numbers in this case, since there were 10 data values. Excuse me. So if I add 26 and 27 together and divide that by 2, you'll get 26.5. So here, the median of the entire data set, which is Q2, that'd be 26.5. Now, the way we find the interquartile range, or IQR, we have to subtract the third quartile minus the first quartile. That's Q3 minus Q1. So for this data set here, Q3 is 28 and Q1 is 22. So 28 minus 22 is going to be 6. So the interquartile range is 6 for this data set. Now, when the interquartile range is reported along with the median, not only do we know the middle, but we also know how spread out the middle 50% of the data are. Now, let's take a look at this example here, example 8. This just deals with finding the range. Well, actually, we have to use the way of finding the range of values here to answer this question. The youngest person in the company is 30 years old. The range is 21. The range of ages is 21 years. How old is the oldest person in the company? Okay, so in this case, sit down with this full screen. All right, so when we find the range of ages, that's just going to be the oldest age minus the youngest age. Now, in that problem, we are told that the youngest person in the company is 30 years old. And the range of the ages is 21 years old. So that range there is 21 years old. So here I want to find out how old is the oldest person in the company. So here I'm going to let X be the oldest person in the company. So notice we have the equation 21 is equal to X minus 30. Now we can find out what the age of that oldest person is using this equation by solving this equation for X. Here I'm subtracting 30, so I need to add 30 to both sides of this equation. So that means X is equal to 21 plus 30 will be 51. So in this case here, the oldest person in the company is 51 years old. Okay. So that's how we pretty much use that range formula. We can find out the youngest person in the company, or we can find the oldest person in the company. All right, questions on this? Okay. And so going back to this, now I did talk about Q1, Q2, Q3, and also we did talk about the minimum and the maximum value, or the greatest and the least. Those can be used in what we call a 5-number summary. Now the 5-number summary consists of 5 things: the lowest number, which is the minimum of that data set; the first quartile, that's the median of the lower 50%; Q1, which is the median, Q2 is the median; and then Q3 is the third quartile, or the median of the upper half; and the highest number, which is your maximum value. Okay. So that's the 5-number summary. You have the minimum number, the first quartile, the second quartile, the third quartile, and your maximum number. And with that 5-number summary, we can create something called a box plot. And what a box plot is, or sometimes it's called a box and whisker plot, that's a way to display data visually and draw informal conclusions. And box plots show only the visual representations of the 5-number summary of the data, which is the median, the upper and lower quartiles, and the least and greatest values in the distribution. So here's just an illustration of just that. Here you have your minimum data points, and then Q1 represents the bottom 25%. Q2 which is your median of that entire data set. And then Q3 would represent the top 25% or the bottom 75%. And then your maximum data point. So with that data set that we talked about earlier, with the measures of spread, we can plot those using a box plot. The minimum was, in this case, 20. So that's a minimum. We found Q1 to be 22, so 22 is that point right there. Q2, which is your median of the data set, that's approximately 26.5. And then Q3 was 28. That's this point. And then your maximum point was 35. Okay. Now, what they did was they drew a box from Q1 to Q3, and the red bar that you see here represents the median. And then they have whiskers from Q1 to the minimum, and another one from Q3 up to the maximum. So that's how we create the box plot from there, from that data set. Okay. Now, in this example, let's say I want to identify the minimum and maximum values, the median, and the lower and upper quartiles of the box plot below. All right, in this case, let's find out what this dot represents here. Okay, that minimum, I'll write this out, the minimum, and then Q1, and then your median, which is also the same as Q2, and then Q3, and then your maximum. So in this case, what do you think would be the minimum? Is 0. And then Q1 would be a 10. And what about the median? Okay, the median, that has to be 20. And Q3 must be 35, and what's your maximum? 70. Okay. So that's all there is to that. Okay. All right, questions on that example? Okay. All right, let's look at this next example here. So let's say we had something like this. To the right are box plots comparing ticket prices of 2 performing arts theaters. And in part A, we want to find out what is the median price ticket for each theater. So for theater A, the median is this bar right here that's inside the box. For theater A, what would be that median? It'll be 30, okay? Because that's this middle, the bar that's in the middle of that box plot. And what about theater B? What would be the median there? 26, okay? So for theater A, the median is 30. Theater B has a median of 26. And then part B, which theater has the greatest range of prices? Which one? A. It has to be A. Okay, the maximum is 36, the minimum is 24. That range there is 12. Whereas for theater B, its maximum is 30, the minimum is 22. So 30 from minus 22 will be 8. So theater A has the greatest range of prices. What is the highest ticket price at either theater? Okay, the 36 for theater A. What about theater B? The 30. But at either one, the highest is $36. Okay, and we'll skip part D, making statements comparing ticket prices at the two theaters. Pretty much if you were to look at that, you could see that theater A has a wider range of prices than theater B. Okay. And this one has nothing about the average, but the median price at theater A is more expensive than the median price of theater B. All right, questions on example 9. Okay. All right, here we're going to talk about outliers. And an outlier is a value that is widely spread from the rest of the group of data. That's one data value, or it could be more than one data value that's far away from all the others. Okay. So in a set of scores like 91, 92, 92, 93, 93, 93, and 94, you can see that the data are grouped close together. So none of those values are widely separated. However, let's say we had a set like 21, and then 92, 92, 93, 93, 93, 95, and 150. Now we got a score of 21 and a score of 150. Those are widely spread from the rest of the data set. And these could be what we call potential outliers. Now, to determine an outlier, it's going to be any value, in this case, that is 1.5 times the inner quartile above the upper quartile or below the lower quartile. And here they're using 1.5 times the inner quartile above, or 1.5 times below the lower quartile. Okay, so here's how we use quartiles to identify outliers. Okay, if we let some measurement called y belong to a collection of numbers in that set of data, we need to identify Q1 and Q3. And we need to identify the IQR, the interquartile range. That's going to be Q3 minus Q1. Okay. Now, for a data value to be extremely low, that data value has to be Q1 minus 1.5 times the interquartile range. You have to compute this first, Q1 minus 1.5 times the interquartile range. And if that amount, if that y is less than whatever this amount is, then we can say that it is an outlier. And then we also have to do this. Q3 plus 1.5 times the interquartile range. And if that data value that we're looking for, if you have data values that are greater than that amount of Q3 plus 1.5 times the interquartile range, then we have a data value that is extremely high. That's what we mean by outliers. Those will be considered to be outliers. Okay. Now, let's look at this example right here on the next page. In fact, we're going to do this together. Now, usually they call this an outlier box plot for the following, for this data set. And here we want to draw an outlier box plot. And I'll go ahead and write this on the board. So here we got 20, and then 30, 67, 82, 112, 114, 115, 119, 122, 124, 125. Yeah, I can do that. One 29, 130, and 142. And I realize that is a whole lot of numbers here. And let's say we want to draw a outlier box plot for this data set. All right, let's see here. We got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here we got 15 data values here. That means I can identify, let's go ahead and identify the middle number here. And in this case, the middle number that has to be this number right here. 19. Okay. So here the median is 119. I'm going to use these numbers on the left to identify Q1. And then these numbers on the right, I'm going to use that to identify Q3. So in this case here, if I look at Q1, I need to look at the middle number of these numbers on the left side of the median. And in this case, it's going to be 82.
You're missing a number, I think, is throw me off. 120, because see, if I look at that 119, not 119.
Oh my goodness. Thank you.
Sorry.
So that's going to mess up everything here. So 119 won't be the median. And then 120, 122, 124, 125, 128, 129, 130, 142. So that means 2, 4, 6, 8, 10, 12, 14. This time I have 16. Okay. So now the two middle numbers are these two numbers right here, 119 and 120. So that means the median is halfway between 119 and 120. Has to be 119.5. Just add 119 and 120 together. That sum will be divided by 2. You'll get 119.5. Okay. So now, this is the bottom half, and this is the upper half. And from that upper half, I can get Q1 and then Q3. So I had to look at these two middle numbers together, the 82 and the 112, and divide that by 2. So 82 plus 112 divide that by 2, this will be 97. So that means Q1 has to be 97. And then for Q3, these top 8, these two are the middle numbers right there, 125 and 128. Take the average of those two. That's going to end up being 126.5. Yeah. Mhm. Yeah, by 2. Because you have 2 middle numbers. Any other questions? All right. Now let's find the interquartile range. The interquartile range is always Q3 minus Q1. So in this case here, Q3 is going to be 126.5 minus Q1. That's going to be 97. So if I subtract 126.5 minus 97, and in the quartile range will be 9.5. Okay. Okay. Now I need my maximum and my minimum points. Now in this case here, this is where I determine whether I have outliers. Okay. To find out my outliers, I need to do this. I need to do Q1 minus 1.5 times the interquartile range. That's what's going to help me determine whether I have outliers on the left-hand side. Now, the other one is going to be that Q3 plus 1.5 times the interquartile range. And this will help me determine if I have outliers on the right-hand side. Okay. Now, Q1 is 97 minus 1.5 times the interquartile range of 29.5. So I'm going to do 97 minus 1.5 times 29.5. And I will have, in this case, $52.75. That's what I came up with. Now,
Q1 minus Q1.
yeah. The IQ, that's the interquartile range. 29.5, that's what I came up with. Q3 minus Q1. Any other questions?
Then you subtract the 29 point.
I multiply. Yeah. First, you multiply 1.5 times 29.5. I know you're using a regular calculator on this one. But now, whatever that is, you have to do minus 97 minus whatever you get for this, which was, and you should get 52.75. I did this on my graphing calculator, which I know probably not going to be able to use. Okay. All right. Now let's take that 52.75. Here I need to find values in this data set that are less than 52.75. Looking at this, what values are less than 52.75? 30 and 20. Those are less than 52.75, less than this amount. So that means the 20 and the 30 are outliers. So off to the side here, I'm going to say what my outliers are. That's 20 and 30. because both of those data values are less than this 52.75. Now I got to do Q3 plus 1.5 times the interquartile range. Now this time the Q3 is at 126.5. And this is going to be plus 1.5 times. Again, that interquartile range is 29.5. Mm-hmm. 170.70. I get 170.25. Hmm? Okay, wait a minute. 126.5. Oh my goodness. Yeah. It should be 126.5. And then plus that, this will be 170.75. Now, are there any values that are greater than 170.75? They're not, okay? So that means that the only outliers that we have are the 20 and the 30. Now, from this information, I can find out what my minimum value is and my maximum value is. That way I can draw the box plot. The maximum is going to be easy to find. What's the highest value that I have here? It's 142. But for the minimum, unfortunately, I can't use 20 and I cannot use 30 because those are my outliers. So the minimum value here will have to be 67. Okay? The minimum will be 67. Now from this, I can draw the box plot. Okay. And this will start at 0. Let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. And with these, you might have to kind of guess at where these are going to be at. The minimum is 67. So no, 67 has got to be somewhere between 60 and 70. So I'll put it about right here. And I'm going to draw a short line here because that's the minimum value. And I might as well put in my outliers, the 20 and the 30. And I'm going to use a asterisk at 20 and at 30 for my outliers. Okay, and I have the small vertical line at 67. Q1 is 97, that's close to 100. So let's see, 97, I'll put it about right here. I'm gonna draw a longer line here because that's gonna be part of the box. Keep in mind, Q1, the median, and Q3 are gonna be part of the box. And here your median is 119.5, which is almost to 120. So I'm gonna draw another line there. And my Q3 is 126.5. Okay. So these three create the box. And I'm going to draw a whisker going from Q1 all the way to that minimum point for that minimum value. And then the max is 142, which is about right here. I might put one on a writing assessment. This right here, that's your median. Yeah, the 119.5. Okay. Which is also Q2. Okay. Any other questions? Okay. So in this case, that's how we draw one of those outlier box plots for a data set. Okay. And pretty much you had to use these two right here to determine whether or not you have outliers. Okay. Right. Any questions? Okay, let me pause right here because I'm gonna have to